Mm-hmm.
Okay, the next problem we have on the list is number 13 in the book, section 6.3. So this question wants you to revolve two equations. The first one, x plus 3y, x plus 3y equals 6, about the x-axis with these boundaries, y equals 0 and x equals 0. So you're going to revolve this about the x-axis. So to help us do that, we're going to draw a graph. This is the y-axis, the x-axis. Remember we have two boundaries. We have the boundary x equals 0 and the boundary y equals 0. So we draw the graph. To aid us in drawing the graph, we're just going to find the intercept on the axis. So to find the intercept on the y-axis, you make x 0, make this 0, and y becomes 2. So you know the graph crosses the y-axis at 2. If you want to find the x intercept, you make y 0 and you find x. So x equals 6. The graph crosses the x-axis at 6. So you draw a straight line. Remember this is also a boundary. This axis and this axis, they're all boundaries. So this is the region omega that we have to rotate about the x-axis. So if you rotate this, it's pretty simple to see that it's going to be something like this. It's going to make a cone. So let's proceed to writing the equations of this graph. And as you can see, it's rotating about the x-axis. So we're going to have to write the equations in terms of y. So x as a function of y. So we'll set up the equation of volume right here. And it's the same equation as the one we used in the previous example, which is v equals 2 pi, the integral of the height times the radius. So the height is going to be this, from the origin to the highest value of the graph, which is 6 minus 3y, because we have to make this equation in terms of x. So it becomes x equals 6 minus 3y. So basically we have 6 minus 3y, and as you can see, it's revolving directly at the x-axis. So your radius is going to be y, just y, because it doesn't have any extra, like the last example had made us revolve around a particular axis. But this doesn't require us to do that. It just wants you to revolve about the x-axis. So the radius is going to be simply y. So you integrate that with the differential element being dy, and you use basically the limits on the x-axis. So we are going to go from, use the limits on the y-axis because you're differentiating along the y-axis. The height is along the y-axis, so you use the limits on the y-axis. So the lowest limit on the y-axis is 0 and the highest is 2. So you go from 0 to 2. And if you solve this, you realize that you have v equals 2 pi, the integral from 0 to 2 times 6y minus 3y squared dy. And from here it's just a simple integration, and this gives us v equals 2 pi times If you integrate this, you get y squared times 3 minus y cubed from 0 to 2. And if you plug that in, you get 2 pi times 12 minus 8, and that gives you the volume as 8 pi. So remember, you revolved about the x-axis, so you have to write the equation as a function of x. And the differentiating element is going to be along the y-axis, because that's where the radius is. So that's how you get this. And then from here downwards, it's just basic integration till you get your answer.